Hello and welcome. In this video we are going to look at creating user keys for SSH access, and the end result of this is that our remote connections between machines are going to be significantly more secure than they were before. So we will look at how we can create paired keys to, as I just said, make remote access significantly more secure so that we can try to keep the machines in our network under our control instead of somebody else's. So in the past, when you've connected to a machine using SSH, you're presented with a login screen. Typically, you're actually given your username as you try to connect, and it prompts you for a password. And if you type in the correct password, you get access. But what happens if that password is stolen or guessed? Or I think I made a comment in another video about one of our users writing their passwords on sticky notes and leaving it beside their machine. Don't laugh, people do it. Or if that password has been compromised somehow, like it was stored plain text somewhere and somebody took that USB key with that information home to do some work and it got stolen from their car. Don't laugh, it's happened. So if somebody else can get access to that password, however they do, steal it, guess it, brute force it, whatever, they can now log in imitating that user. So how can we prevent this? We can use something called a paired key inscription or paired key encryption, pardon me. And well, that involves the use of a public key paired with a private key that allows users to authenticate to prove who they say they are without transmitting a password across the internet. So to do this, there's a couple of things that we need to do on our client machine. Number one is generate this key pair. And we can do that with a nice simple command, SSH keygen. There are options you could provide it to specify the encryption standard you want it to use and where you want it to store the file. I'm not going to go into those. We're going to use the default values for it. They're pretty sensible. And once you understand how it works, you can certainly use a man page to find those options yourself. Once we use that command to generate our paired key, though, we will then take the public key, it's one half of that key, and we transmit that to the server that we want to log into. You can do that manually, and I actually have a separate video about this because we might be transferring keys for somebody else. Or, assuming we can still log in, we can use the command SSH copy ID. Now, I've mentioned, before we actually run these commands, this concept of a paired key. So you have a public key and a private key. The math involved in this is well beyond what I'd like to talk about in this video. Suffice to say that the two keys work together, they only work together, and the way the math behind it works, you protect your private key. You never share that with anybody else. But you can give your public key to anybody you want to. And what happens is when you try to log in, the machine that you're logging into that now has a copy of that public key encrypts a message using that public key, sends it across the network back to you when you try to log in, and theoretically, the only person who can decrypt that encrypted message is whoever has the private key, which should only be this one user. So then they decrypt that message, send it back to the server to prove I really am who I say I am. And it's, well, theoretically more secure because your public or private key shouldn't have been shared with anybody. It's not written down beside a terminal for somebody to walk by and memorize, or printed out in a piece of paper that gets thrown out and somebody finds, or whatever else. So let's go over to my machines. I have demo and demo 2. I'm currently logged in as an admin on both. And supposing that we were trying to connect from demo 2 to demo, we could always use the old standard SSH command and get prompted for our password. I may have mistyped that. There we are. If you get the password right, you've logged in. But again, passwords can be broken through. So what we will do is SSH keygen to generate this paired set of keys for this user. Again, I could specify some options to pre-enter the information I'm about to be prompted for, but if we don't enter those options, we get prompted for it anyway. So it's generating this public and private key pair using RSA. The file in which you want to save, you could specify that this goes somewhere else. I'm going to leave it in the nice default location, which is inside that user's home directory. There will be, and if it's not there, this will create it, a hidden directory .ssh, and inside that, it is going to save the private key in ID_RSA, and the public key will take that name just with .pub on the end. So if I don't specify something else, the public key would be ID_RSA.pub. Enter a passphrase. This is similar to a password, but not quite. This is used locally only to get access to use this key. This passphrase never actually gets transmitted across the network, and this should be something separate from your password so that in case your password does get compromised, we still have an extra layer of security protecting the other machines in our network. So I'm going to put in a passphrase, which I mistyped. As long as they're the same and I get it right both times, it lets me know your identification, that is your private key, has been stored in your, well, the default, your home directory .ssh ID_RSA. The public key is that same path, just ending in .pub. And normally we probably wouldn't want to show some of this stuff to another user, but these machines are only accessible in this private network, and they're going to get re-imaged very shortly after this video, so I'm not too concerned about people seeing aspects of this key. If we head over to that directory, there we are, ID_RSA, ID_RSA.pub. And if we look inside that, I'm just going to do the public one here. This is what this looks like. It identifies itself as an RSA key for SSH. It has this long string of semi-random, well, random-looking data that, if I'm remembering the math right, is actually based on an extremely large prime number, and that identifies what user, what machine this key is for. So now, I have generated my key, and I'm just going to demonstrate the permissions on this because that's also really important, which I do go over in a little more detail in another video. So the SSH directory, well, .ssh, the user should be the only person who can access. So read, write, execute, nobody else gets anything. And if I head over to SSH, the public key, everybody can read. Well, everybody can be allowed to read. It's public. They're supposed to be able to see it. Nobody else is allowed to edit it, though. And executing, it's not a script, so that just doesn't make sense. Anyway, the private key, the only person who can have access to the private key is that user. So permissions 600, or as for the public key, 644 is fine. So now we have this key. It exists, it's on our machine. Now, in order to be able to access the other machine, we need to transmit the public half of that key to the other machine. And there's a nice simple command for this, assuming we can still SSH with a password. So we will SSH copy ID, and again, there are options. For example, if you stored your public key somewhere other than the default, you can use -I to indicate that. I'm leaving it in the default location though. It's nice and simple. So SSH copy ID and admin at demo. Of course, I'm currently logged in as an admin, so I don't even need to repeat that. I can just say copy ID over to that demo machine. It is going to say, I'm trying to transfer one key. Okay, you do still need a password to log in, so put in your password. And it will tell me it transferred one key, and it reminds me you should immediately try to log into that machine to double check that this worked. So I'll do that. So now I need the passphrase that I created when I created that key. Again, that doesn't actually get transmitted across the network. That stays local on this machine, just to prove I really am this user to access this key. And then I don't actually need to enter a password to get to this remote machine. So what's actually happened on that remote machine? Well, sorry, I want AL. LSAL, there we are, .ssh, so it has this hidden directory. Again, this user is the only person who has access to it. And if we go into it, what it actually did is create this file, authorized keys, where the user has read-write and nobody else has any permissions. So nobody else can come along and mess with our keys. And what is stored in there is that public key from that other machine. If we had keys set up for multiple machines to allow us to log in, you would just see, well, multiple different keys in here. But if we really wanted to go back and compare, I mean, I'm not going to sit here and read every character, but AAAA, B3NZA, C1C2E. Chances are, if this was a different key, we'd be seeing differences already. And yeah, these look the same, because it is the same. We just transferred it. Now what you'll notice about that is in order to transfer that key, I did need a username and a password on that remote machine to do that transfer. In a separate video, which I think I actually have the next slide about. Okay, yeah, I have that in a separate video on the next slide, so we'll talk about that in a moment. When we are transferring those keys, it is really, really important to remember which one is the public key. You do not want to share or transmit your private key anywhere else. Potentially, you could set up a private key to allow you to log in from multiple locations. Realistically, though, your better bet is have a separate private key for each machine. It just keeps the network a little bit more secure. And we saw, okay, I had to enter a passphrase. It is theoretically possible to generate those keys without a passphrase. Do not do that. If you do that and somebody gets access to the machine you generated that key on, and then they don't need a passphrase to use this key to connect to another machine, you have just extended the reach of whoever's breaking into your network, and you really don't want to do that. So make sure your keys include a passphrase. Now you may have noticed with the way that I transferred the key on the previous slide with that SSH copy ID command, I was one last time prompted for my password in order to transfer that key. There's actually a parameter in SSH once we've set up keys where we can say, I no longer even accept password-based authentication. So I'm going to edit the config file. And what I'm looking for, it's permit password authentication or just password authentication. So the default is to allow password authentication. But once we have our keys set up, we might take this and change password authentication to no. At that point, we will now use key-based authentication, which is a whole other parameter that is currently set as a default. Pub key authentication, yes. So I will save that. I will restart the server. Well, restart the service, pardon me. No errors, that's good news. I can still, using my key, I can still log in, using my passphrase, of course. But if I try to log in without a key, permission denied. You can't enter a password to get access to this machine anymore. So this means that in order to get in, you must have a key set up, which is great. It means that people have to be logging in from the machines they're supposed to be on, they have to actually be authenticated as themselves, and they have to know their passphrase. So it just makes it harder to break into your network. However, this means when I set up a new user, I now have to find some way to transfer their key across the network to that new machine. There's a couple of ways you could do this. You could temporarily re-allow password-based authentication, have them transfer the key, and turn that back off. But the better way, and I do have a separate video that comes right after this one, the better way to deal with that is have them send you their public key, and then you as the admin can set it in the correct location, which, surprise, surprise, we've already talked about that hidden SSH directory authorized keys. You can, as an admin, edit that manually, and I do go over how to do that in the next video. That way, that remote user, they set up the passphrase in their key, they give you the public key, you install it on the machine, and now they have key-based access to that machine. So this way we can be sure the right person is logging into their account, and we're limiting unauthorized access. So what we've looked at in this lesson is how we can set up SSH keys for our users so that we can improve the security of our network. We can limit unwanted access between machines. And I've said it a couple of times. I'm going to say it one last time as a sign-off. The next phase of this would be transferring keys for another user. That's the next video. So I will see you there.